Hello and welcome to yet another video of Cornerstones of Math. Today we will solve the following problem. The position of a point P on the xy plane is given as a function of time t as follows. So x, y is given as sine t, cosine 2t. Find all positions of P where its speed is maximum. Alright, let's solve this problem. First of all, the speed s of point P is defined as the magnitude or norm of the velocity vector v. So first we need to find the velocity vector. The velocity vector can be obtained from the position vector x, y by differentiating each coordinate with respect to time t. So using the given position vector, the velocity vector is given as cosine t, minus 2 sine 2t. And here, using this trigonometric identity, let us express this coordinate as minus 4 sine t cosine t. Therefore, the square of the speed of point P is the norm of the velocity vector squared, which is cosine t squared plus minus 4 sine t cosine t squared. So we have cosine squared t plus 16 sine squared t cosine squared t. And here, let us change this sine squared t into 1 minus cosine squared t. So we have minus 16 cosine to the power of 4t plus 17 cosine squared t. So we have to find time t that maximizes this function. The best way to simplify and investigate the maxima here is to make a substitution by letting cosine squared t as capital T. Then we have s squared equals minus 16 capital T squared plus 17 capital T. And this is a quadratic function, so let us change into the vertex form. So first we write minus 16 times t squared minus 17 over 16t. And we have to complete the square, so let us write minus 16 times t squared minus, and the next term is 2 times 17 over 32t. And in order to complete the square, we add 17 over 32 squared, then we subtract 17 over 32 squared. So this part becomes complete square, which is t minus 17 over 32 squared, and we have plus 16 times 17 over 32 squared. So in the end, we have minus 16 times t minus 17 over 32 squared plus 289 divided by 64. And let us do not forget the important thing to do whenever we make a substitution: finding the range of the newly introduced variable. Here, capital T equals cosine squared small t, so we have the range capital T is greater than or equal to 0 and less than or equal to 1. Therefore, the square of the speed is maximum when capital T equals 17 over 32. That is, when cosine squared small t equals 17 over 32. And position of point P is given like this. So x coordinate is sine t, which is plus minus square root of 1 minus cosine squared t. So plus minus square root of 1 minus 17 over 32, which gives plus minus square root of 30 divided by 8. And the y-coordinate is given by cosine 2t, which equals 2 times cosine squared t minus 1. So 2 times 17 over 32 minus 1, which is 1 over 16. Therefore, positions for maximum speed are plus minus square root of 30 over 8, 1 over 16. Using the Desmos graphing calculator, we can sketch the parametric curves like the one given in this problem. You have to use t for a parameter, and you will obtain this blue curve. Now if you're thinking, this looks like a parabola, then you are right, because from this position vector, we can also write this as sine t, 1 minus 2 sine squared t. So we have the relation y equals 1 minus 2x squared, where x, which is sine t, has a range from -1 to +1. Now, in order to demonstrate the movement of point P, let us create a point by using new variable k with the same expressions for coordinates. This will create this green dot P. Now we can increase or decrease the value of variable k at a constant speed, which represents the constant flow of time. Also, we have two red x's, which are the answers we have just obtained for the maximum speed. And here, you can actually observe that the green dot moves the fastest when it's passing two red x's. And that was all for today's video. Thank you for watching, and I will see you in another video.